Yeah.
So have you started recording?
Yes.
Good. So today we're looking at OOP in Python, and we'll be first of all covering the very basics of how do we make classes and how do we access some of the methods or some of the instances in our classes. So in the start, you might find some terms of the OOP very confusing, but as we go on, I'll make sure that you get familiar with all of these terms. So first of all, what is a class? So class is just a combination of methods or some instances that are very related to one particular type of data set. So for example, if I want to just tackle or if I just want to handle one particular type of species, like if I want to just uh, cover my admin panel of my company, or if I just want to look at my employees and I want to handle their data only. So for that purpose, we use classes in Python. Okay. So how about we start with making a simple class? So making a class starts with this. We need to say class, and class needs to be in small letters like CLASS. And then we need to say this. We need to say the name of our class. And one more thing to remember is that the name of our class must be in the capital letters. So it should have the first letter as capital. So I'm going to say class, and then I'm going to say point, like this. Okay.
Right.
Okay. So then we need to give our colon here, and then let's press enter. Now, just for the very beginning, how about we add some of the random methods that can be accessed outside of the class. So I'm just going to say def. So methods are actually the functions that are defined under our classes. Okay. So methods are very important aspects of a class. So I'm going to say def, and then how about we make our first method as move, and then we're just going to give some brackets here like this. And as soon as I give brackets, as you can see, we have a self in it. So what does a self represents? So the self represents that this particular method belongs to a one particular instance. So I will explain you what instance is, and we can have one or more than one instances of a particular class. Okay, so we said def and move and self. So this one is self is referring to one particular instance. Now, within this function, I'm just going to say print, and just for the example purpose, I'm going to say moving. Okay, so we have one function. Let's go ahead and create another function. So I'm going to say def, and in here, we can make another function about draw. Okay, so I'm just creating some random functions just to make things clear. So we said draw, and then a self will pop up automatically. And then we'll say again print, and in here I'm just going to say drawing. Okay, so how about we just keep our class, our first basic class till here, and in here after our class we need to give at least two spaces. Okay, so 1 and 2. So this will show that we are out of our class now. And now when we are out of our class, we need to make an object of a class. Okay, so what is an object? Object is just a variable which will represent class. Okay, so if you want to use or if you want to access some methods of a class, we access them using our object. So I'm going to say this. How about I say point 1? Okay, so point 1 equals to, and in here I'm going to say point. So this point will be the name of my class. So it will be written like this. Okay, so point 1 is now an object of my class. Okay, so in here now, using my point 1 object, I can go ahead and access any of the methods that I want to access within my class. So I'm first going to say, how about point 1? Now see, as soon as I say point 1 and as soon as I say dot, we have two methods available in it: draw, move, and init. I'll talk about what init is, but how about we first use those draw and move functions. Okay, so I'm going to say, how about first say move. So This one was our first method. How can we access methods using our objects? Okay, let's go ahead and try with the second method. I'm going to say point one dot draw. Simple. And let's just first go ahead and run it to see what happens. So we'll right click on that. Let's run this program. There we go. As you can see, it first printed moving and then it said drawing. Okay, so now let me clear some of the names that we use in our OOP. So this point one was the object of a class. Okay, this def, move, and draw, these are methods of a class. Okay, so we have used our object to access one of the methods in a class. So how about we create another object? So I'm going to say point two. Instead of point one, I'm going to say point two. Point two equals to point, like this, and some brackets as well. Okay, so I've created another object of my point class again. I'm going to press enter, and there we go. Now we can say point two, not point one, but point two. Point two dot draw. Now, why have chosen a point two as well? So the reason I have chosen a point two is just to show you how self works. So point one dot move, whatever I write like moving. So the self was actually referring that I am being used by point one. Okay, so now I have said point two dot draw. So the self is referring like now I am being used by point two, like I'm being used by another object. Okay, so you understand it? Okay, so this one was the purpose of our self or our objects. Okay, so this one was a very simple method of how can we access some methods in a class. How about we now create some instances? Okay, so outside of a class, we can also declare some variables that belongs to a class. Okay, so how about I first create a point one? I'm going to say point one dot x. Okay, point one dot x equals to, and in here I'm going to give anything like point one dot x equals to 7. Okay, and then how about I press enter, and then let's go ahead and create another instance of my point one object. So I'm going to say point one dot y. As we all know that points, like a point, have some x or y coordinates. I'm going to say point y equals to 9. Okay, so this is how we can create some instances being outside of the class. Okay, so I have created some x and y instances of the point one object which belongs to a point class outside of the point class. Okay, let's press enter again, and now I'm going to do the same thing with my point two object. I'm going to say point two dot x, and in here we can give any amount as we want. So now I'm going to say 5. Let's press enter, and then I'm going to say point two dot y equals to 9, just for example purposes. Okay, so we said point one dot x, we said point one dot y, and we have also created point two dot x and point two dot y. So we have actually created, virtually we have created 2 points, point one and point two, which have their own x and y coordinates. Okay, so this one will be a very perfect example of how and why do we use classes. Good. So we have used some instances. How about we go ahead and start to print them? So I can say this, print, and then point one dot x. Okay, and we can do the same with our print point two. How about if I say point one dot y, like this, and then we can do the same thing with our point two as well. We can say print point two dot x, and then we can say again print, and then point two dot y. Okay, so let's go ahead and try to run this and see what happens. There we go. We first said 7 as point one dot x, then we said 9 as point 1.y, and then we have 5 and 9 that belongs to the point 2 object of our point class. Okay, so this is how we make instances and we access them being outside of a class. But the thing is, uh, creating those instances outside the class is not very secure. Okay, so anyone can go ahead and create any instance being outside of the class and also can give them values or can change those values, but we don't want that. Okay, so just to solve this problem, what we do is we create an initiator. Okay, so all the classes in Python do have an initiator. In C++, they also have a thing called as constructor, but in Python we call the same thing as initiator. Okay, so if you just go ahead and do this, I'm going to say def and give 2 underscores. As soon as I give 2 underscores, it will understand that I'm going to give an initiator function. I'm going to say underscore. As you can see, we have init and self, like this. Okay, and then we can press enter, and in here we can actually define our x and y variables. Okay, so how about we say self comma x comma y. I have already explained to you the purpose of self here. The self is referring back to which object it is being called for. So like point 1 is calling it or point 2 is calling it. Okay, and then I said x comma y. Why I have used the x comma y? This x comma y, I have used them so that whenever I define an object, I give it as the default values. Okay, so as soon as I make another object, I'm going to give those x and y values. I'm going to pass them to my point class and they will be automatically assigned to it. I'll show you how it works. So first, how taken our x and y values. Now we need to assign them. And how can we assign them? We're going to say this self dot x equals to the self.x should be equals to what? It should be equals to x. Whatever the value user gives, it will be equal to that particular value. Okay, so we can say anything. We can say self.y or self. Any variable. We can say self.t as well. It doesn't matter. I'm just saying self.x for the explanatory purpose. Okay, so we said self.x equals to x, and we can say one more thing. We can say self.y equals to y. So this is done. This is usually done in Python just to keep things simple. Okay, so the self.x means that there is a variable which belongs to one particular object, and this variable is going to be equals to x. Okay, and self.y is just another variable which belongs to a one particular object named as point 1 or point 2, and this object also have an instance named as y, which is the value whatever user gives us, and in here it is named as y. Okay, so we said we gave an initiator, we gave 2 values x and y. Now comes the part where we are going to assign them. So first of all, I'm just going to comment this out because now we have to use another method of doing things. Just press enter, and in here now if I go ahead and try to make another object, what I'm going to say point 1 equals to point, and then what? Then we need to say brackets, and within those brackets now I need to initialize my values. Okay, so what do you think? What should we initialize it with? So how about we say 2 things? We can say 2 comma and 5. Now this 2 comma 5, what will be done with them? As you can see, we have x and y there. Why we have x and y there? It shows that we need to give 2 inputs to our classes to create an object named as point 1. So these x and y values will be automatically given here, in here, and they will be automatically be assigned to our self.x and self.y. Okay, so remember one more thing. Whenever we use a variable within a class, we should use it with self.x. Okay, so I'll also explain you how many variables are there in a self. In a class, we have some local variables, we have some class variables as well. We will talk about them later. But first, these are class variables like self.x and self.y. Good. And how about now we say this move instead of move? How about we say
Could you please make the fonts a little bigger?
the font's bigger?
Yeah.
We can use a magnifier, but that won't be this much cooler. So to make fonts bigger, we need to go ahead into this effector, I think, or view, and I think we need to go to our settings first here. In here, we're going to say editor, and then font size. So how about we say 20 now? Is it good? Or a 15 will be good, I think. Yeah, I think it will work. Okay, so as I was talking, like we have created an object named as point1, and this point1 will have 2,5 automatically assigned to its x and y within a class. Okay, so this is how a simple class is being made. We can also say, instead of this move, we can also go ahead and say print x. How about we give a function named as print x. Let me just open my keyboard here. Yep. So we can say print and then x. I don't think we can use this. No. Yeah. So another in here we can say print y. Print y. And inside here, now we're gonna change something. We're gonna say print, and in here within those brackets, we are going to say not just print x. We're going to say self dot x, like this. Okay, because whenever we are within a class, we need to call our variables named as self.x. Okay, and instead of here, we're also going to say print, and in here we're going to say self.y. Okay, so I have created a simple point class which will have two values as arguments like x and y, and they will be assigned to two variables self.x and self.y. And then I have made two methods named as printx and another method named as printy, which are going to give us the values of x and y. Okay, so in here outside of our class, now I'm going to call our method. So how can I call a method? I can give this. I can say point1 dot printx. Okay, and then we can say point1 dot print y, like this. You see, we have two methods, print x and print y, like this. Let's go ahead and run it and see what happens. There we go. So both of these methods will now give us 2 and 5 respectively as the values of x and y. Okay, so I hope everything is clear to yet.
Yes.
How,
Yes, it is.
okay, good. So how about now? So do you want me to, like what I usually do is I ask my students to go ahead and create a class of their own. So if you want, we can go ahead to
We
your
can
screen.
we can we can move forward.
Okay, good. Okay,
Okay.
we can move forward. So this was the simple class. This was a very simple, any class that we want to create. We can go ahead and create as much as methods we want. Like I'm gonna create another class if you want, like another class named as parrot. How about this? So you can say class
Uh,
And then,
what we can do, we can create another file, new file,
okay,
and create new class.
yep.
Then we can move with like inheritance, another concept.
Okay, no problem. How about we go ahead with inheritance? Inheritance is
Right.
another very important topic when we talk about OOP. So we can create another file in here, and I'm going to say inheritance.py. Nice. So I'm going to start up with making a simple class first. So how about we'll make a class named as person. This is something very interesting. So I'm going to say
Okay.
class, and how about we give a person to it? Okay, so class and person, and then we need to go ahead under this class. I'm going to say, how about we first create an initiator? Okay, so I'm going to say def. As I told you, we always need an initiator which will initiate the values that we want to use. So I'm going to say def, and then let's give some underscore with it, underscore underscore init self, and in here I'm going to say comma. And for a person, like we need, how about we first go ahead with name only? So I'm going to say name. Okay. As we
Okay.
move on, we'll keep on adding some other instances in it as well. So as soon as I say self comma name, I also need to initiate this. I also need to assign this name to any variable, and in here in my class, I'm going to say self dot name equals to name. Okay, so this was the self dot name is our object variable, and it is equals to name. Good. So how about we go ahead and simply create another object named as, so another method named as def, and in here we're going to say get name. Okay, so as soon as I give brackets, we'll see self popping up. Let's press enter, and in here, how about I just give print, print, and as you all know, to print any variable used within a class or assigned within a class, we will say self dot name. Okay, and how about I just go ahead and create another variable, and within this variable I'm going to say one more thing. I'm going to say just check if he is employed or not. Okay, so this code will become more familiar when I go ahead and create another class. So for now I'm just going to create another method named as is employed. Okay, so as soon as I give some brackets again, self will pop up, and in here I'm going to return.
Self is instance variable here, right?
No, self is not a variable. It's like something referring back to our object. Self refers back to which object is calling it. So as you know, in my last file there, as you can see, I created 2 points. Like this was point 1, and we also have point 2. Okay, like this. So point 1 was one object, point 2 was another object. So point 1 will access this method, and point 2 will also access this method. As you can see, both of these methods are being called with different objects at the same time. So how do Python differentiates between them? So for that purpose, self is used. Self is just used to refer back to which object is calling it. Okay. So in here, we're just going to return false. Just to take an example that till now, a person is just not employed. Okay. So we can go ahead and create create an object of person class. For that purpose, I'm going to say, how about I say arbaz? Arbaz equals to, this name is a little bit messier. How about I say Ali equals to, and I will say person. and within those brackets, we need to give the name. As you can see, it says give a name. And in here, I'm going to give a name like the inform variable. I'm going to say Arbaz. Oh, sorry, Ali, like this. Okay, so we can go ahead and use our methods as well by saying this Ali dot, and we have two methods available: get name and is employed. So we can go ahead with get name. Okay, and we can also use our another method named as is employed. So that we're going to say Ali dot is employed, like this. Okay, so first of all, I'm going to go ahead and run it, and then we'll come back to our inheritance process. Uh-oh, we need to run our inheritance.py file. There we go. It first gave us Ali, and for this, I need to print. Print Ali dot is employed. Then it will give us a false. I think then it will give us a false. Or how about we go ahead and run it again? There we go. It said false. Okay. So this was how we created a person's class. And now what I'm going to do is I'm going to create another class named as employee. And within that employee class, I will go ahead and inherit the class from a person class. So for that purpose, how do we do it? Let me create some space here, and I'm going to say this: class space employee, and within those brackets, what I'm going to say person. As soon as I say employee and within those brackets I say person, this employee class will become a child class of a parent class named as person. Okay, so we're going to say this employee is being inherited from a person class, and whichever class is being inherited from another class, it will have the properties of that class, which means that it will have self.name, get name, is employed within it, inherited automatically from the person class. Okay, I hope you understand that. So we just need to give a colon there and press enter. Now we actually don't need to go ahead and say like we don't need to go ahead and say what is his name and what we also don't need to give a get name method as well. We just need to go ahead and say is employed or not, because previously when we were in our person class, a person was not employed, and as soon as it goes under our employee class, it will now become employed. So instead of false, I'm now going to return true in my is employed, and you say DEF as well. Yep. So DEF is employed. So, and let's press enter. And now instead of false, I'm going to return true. Why? Because now this employee class is inheriting from a person class, and if an object is being created using employee class, he needs to be employed. Okay, so there's one more thing for you to learn. Whenever you are inheriting from another class, you can go ahead and change their method as well for your own self. Okay, so how do I use it now? I'm going to go ahead and remove some spaces to, yeah, so we need to give 2 spaces. Yeah. And as you can see, I first created a person. Now how about I create an employee? And employee will also be named as, how about we say John. John equals to, and now I'm not going to say employee, now I'm going to say person. I'm going to say employee. So employee, like this, and we just need to give, in here we can say his name, like John. As you can see, the name automatically pop up. We haven't created its initiator. We haven't created an init function, but name just popped out because this employee class was inheriting from our person class. Okay. So how about we just press enter now, and we can say this. We can say John dot, and there we go. We have this get name method. But as you can see, we don't have a get name method in our employee class. How did get name came? Because this employee class was being inherited from a person class, and that person class had a method named as get name. Okay, I hope you understand that.
Right.
Right, so let's go ahead and press enter. And if I now go ahead and print John dot is employed, what do you think? What should I get? If I say John dot is employed, I'm sure we get a true, because we are creating this John from our employee class, not a person class. Okay, so let's go ahead and run this. There you go. We first got Ali, then we got false, and then we have this John, which came from our
John is
John get
true.
name, and then we said it's true. Why it became a true? Because I created John from my employee class.
Correct.
Okay, so I hope you understand that as well. So this is how a simple inheritance works. You can go ahead and create any complex methods, or we can add any much of some values or methods in it. Okay, so for the next task, how about we go ahead and do some practice over our inheritance. So give me a while. I'll go ahead and create another example for our inheritance.
We can take 15-minute breaks.
Okay, if you can please give me a 15-minute breaks, that will
Okay.
be very
Okay.
fine.
Thank you. I'll knock you when I'm here. Okay.
Okay, good.
Thank you.